కొంతమంది ఇంకా లాగిన్ అవ్వాలనుకుంటే కదా 38 మెంబర్స్ ఉన్నారు. Okay, so let us start. So we were discussing angular velocity and angular acceleration, and last class we have seen what is the angular velocity direction and how to decide the angular acceleration direction. Okay, angular acceleration direction depends on the whether omega is increasing or decreasing. So I hope you revised the last part. Okay, na? Last class. But angular velocity direction depends on the sense of rotation. Okay, so these are the things we have seen. So let us go to the now kinematics of circular motion. That only we are doing actually. In linear motion we have seen when acceleration is constant. If a is constant, if linear acceleration is constant, if linear acceleration is constant, how we decide the velocity after some time t? Suppose initial velocity is u, then what is the velocity after some time t? How to write down when acceleration is constant? We know that v is equal to u plus or minus at we wrote. Do you remember? Where v is the linear velocity, u is the initial linear velocity. So everything is related to linear motion. So what about the next equations, other equations? So displacement in t time. Displacement in t time is ut plus or minus half at square. V square minus u square is equal to plus or minus 2as. And displacement in the nth second. Displacement traveled in the nth second. So this is 1 second duration journey. Okay. So u plus or minus a by 2 into 2n minus 1. So all these equations you can write down when a is constant. If a is variable, if a is variable, okay, so then a value you can write down. You can write down acceleration is dv by dt. Okay, so from this you can find out the velocity by integrating a into dt. You will get, okay, dv is equal to a into dt. Now integrate, then you will get the initial velocity to find the velocity 0 to t time. Actually, this equation also came from here because acceleration is constant. Remove from the integration, then automatically you will get the first equation. I think all of you remember this thing, right? So again, v can be written as ds by dt. You can find out the displacement, or acceleration we can write down dv by dt. No, acceleration is, this can be written as dv by dx or dx, okay, na? And dx by dt. So then I can write down a is equal to dv by dx into v I can write down. So acceleration can be written as in terms of v and x. Then if you integrate this, then you will get the third equation by taking the acceleration constant. So when acceleration is variable, then you have to use either derivative or integration. When acceleration is constant, you can use kinematic equations. This is completely or purely for linear motion only. And already we discussed this part in kinematics. In kinematics, we have done that, right? Okay, na? Now the question is, let us go with the rotatory motion or angular quantities. Okay, na? What is the relation between angular quantities? If I take angular quantities, how to write down the relations? What are the meaning of angular quantities? Theta, omega and alpha. Theta, omega and alpha are the angular quantities. You can write down something like this. Relation between okay, na? Angular quantities, theta, omega and alpha. Angular displacement, angular velocity, angular acceleration. Can anyone try for relations? If alpha is constant, then how to write down? If alpha is constant, then how to write down the relations? Anyone? Try yourself. If you want, or you check whether you want to copy this or not. There is no restriction to copy it. You know these things, na? Just I wrote for reference. You want to copy or not, your choice. But you try to write down the quantities here. Initial angular velocity is omega naught. Let us say initial angular velocity is omega naught. Then what will be the angular velocity after t time? After t time, what would be the angular velocity? So that you have to write down expression, okay, when alpha is constant. All of you try. Still some videos are off. Okay. Please write down and follow the things properly. Okay, na? Wrote down. See, if alpha is constant, let us say angular velocity after some time t is equal to initial angular velocity plus or minus alpha t, same as it is, no doubt. Here final velocity is equal to initial velocity plus or minus acceleration into time. Final velocity is equal to initial velocity plus or minus acceleration into time. But these are linear quantities, these are angular quantities. Just replace the displacement with linear displacement with angular displacement, linear velocity with angular velocity, linear acceleration with angular acceleration. That's it. You'll get the kinematic equations in rotation. Similarly, how the second equation will turns to be? Second equation will become, here linear displacement is there, no? Now convert into angular displacement. Then it is theta. U means initial velocity. Initial velocity I am writing as omega naught. Omega naught into t, okay, na? Plus or minus half alpha t square. In the place of linear acceleration, I am writing angular acceleration. Okay, na? So similarly, v square minus u square is equal to plus or minus 2s. How to write down? Omega square minus omega naught square is equal to plus or minus 2 alpha theta. Okay, na? In the place of a linear acceleration, we are writing angular acceleration. Just we are replacing all the angular quantities. That's a simple thing. Then what is the angular displacement in the nth second? The angular displacement in the nth second is initial velocity omega naught plus or minus alpha by 2 into 2n minus 1. So everything goes same. Okay, na? If alpha is variable, then what to do? If alpha is variable, then we can write down the integration of derivative things. If alpha function is given, then alpha is equal to what we can write down? D omega by dt. Then if you want to find out the angular velocity after some time t, so d omega is equal to alpha into dt. Now integrate. So initial angular velocity to final angular velocity 0 to t time. Okay, na? And then what is the angular velocity I can write down? D theta by dt. Okay, so then I can write down d theta, angular displacement. If you want to find out omega into dt, you can integrate. So like that you can convert however you want. It all depends on what function is given and what you want to identify. Okay, suppose omega function is given, you want to identify angular acceleration, then derive it. Omega function is given, if you want to find out the displacement, then you integrate it. Okay, na? So again we can write down alpha as, this is one important expression in questions, d omega by dt. This can be written as d omega by d theta into d theta by dt. Okay, so then d theta cancel out, you will get d omega by dt only. Then what the d theta by dt is called as? D theta by dt is called as angular velocity. Then alpha we can write down as omega into d omega by d theta. This is the alpha value. Some important relations to solve the questions. Okay, na? So you can apply all these equations according to the situation. See, these equations you can write down when only alpha constant. When alpha constant, you can write down the equation. this formula and solve the question. If alpha is variable, then you have to think about the how to integrate or how to derive the things. Okay. So however you calculated uniform and non-uniform, uniform motion and non-uniform motion in kinematics. You remember, na? Uniform motion and non-uniform motion, one dimensional, 1D. Okay, all of you wrote down or writing? Vamsi Krishna Reddy, Tejeshwar Reddy, why your videos off? I think Vinita Reddy is having some problem in video. Every day it is off. Sai Charan, okay, completed. Very good. Hari also completed. Saiteja is not there. Saiteja, Manish. Manish is there, I have seen. Completed, okay. So we got some idea related to what? Related to relation between angular and angular quantities. We know the relation between linear quantities. Now we are able to identify the relation between angular quantities also. Okay. So let us see a question related to this. Okay. If a particle, all of you wrote down or anybody writing? Let me know after this. Okay. If a particle, you people also write down along with me. If a particle is moving in a circle of radius, moving in a circle of radius, 2 meter, circle of radius 2 meter with angular velocity, with angular velocity, omega is given as 2 plus 40 plus t square. Okay, now I have given the angular velocity as a function of time. I have given the angular velocity as a function of time. Angular velocity units are radian per second. Angle rotated by time, no? Angle is in terms of what? Radians. Radian per second will give you angular velocity. So that is the unit of angular velocity. Okay, na? So angular velocity is variable with the time. As the time changes, angular velocity changes with angular velocity. Then find tangential acceleration and centripetal acceleration okay, at time is equal to 2 seconds. Okay, this is the question. At time is equal to 2 seconds, we require the what is the centripetal acceleration, what is the tangential acceleration of the particle. At time is equal to 2 seconds, what is the centripetal acceleration and what is the tangential acceleration of the particle? That is the question. Okay, omega as a function of time as given. So board will become clear, don't worry. Yeah. So all of you solving or not? 8 comma 16, Manish? Okay. Yeah, I think you can solve this question. This is not a big task. If you concentrated last 2 days classes, you can solve easily. A is equal 16, alpha is equal to 8. Okay. Saichar got 4 and 8. Saiteja got alpha 8. What about angular velocity? Eight comma 16. Okay. What about others? Remaining people are doing or not? No answer from other people. Kavish, you got 8 and 10. Okay. Satyaswarup video is off today also. Yashwant video is off today also. Jivita same. Grace also video is off. So every day you people only, I mean, same people only getting the same, video is off. Bhavana got 8 comma 16. See, for tangential acceleration, what we require? We require the alpha value because I don't know how many of you remember the tangential acceleration. What the tangential acceleration is equal to? R alpha. Tangential acceleration is R alpha. So we require the alpha value. Then how to go for alpha values? Now omega as a function of time is given. Then alpha can be written as what? D omega by dt. So that means d by dt of omega value 2 plus 40 plus t square. Okay, na? Now, if you are going for derivative of angular velocity, then you automatically will get angular acceleration. So then angular acceleration is equal to derivative of 2, 0, derivative of 4t, 4, plus derivative of t square is 2t. Then what the alpha value is equal to? 2t plus 4, what are the units? Radian per second square. Okay, na? Omega by time, no? Omega by time is angular acceleration. So omega is radian per second, then angular acceleration is radian per second square. Okay, fixed answers given by Sai Charan. Okay, let us see. So this is the alpha value. Now alpha is variable or constant? Alpha is variable. Alpha is depends on the time now. But we require the tangential acceleration at time is equal to 2 seconds. So at time is equal to 2 seconds, what is the alpha value? At time is equal to 2 seconds, what the alpha value is equal to? Alpha value is 2 into 2 plus 4 will give you how much? 8. 8 radian per second square is the alpha value. Alpha value got 8. Then what is the tangential acceleration at time is equal to 2 seconds, which is r alpha, no? R value is given how much? 2. So 2 into alpha value is 8 at time is equal to 2 seconds. Then total 16 meter per second square. That is the what? That is the tangential acceleration. So tangential acceleration will be 16. 1/6. I think Manish got correct answers. Similarly, what is the centripetal acceleration? Centripetal acceleration I can find out. Centripetal acceleration is centripetal acceleration is equal to v square by r. Centripetal force is mv square by r. Centripetal acceleration is v square by r. So this I can modify in terms of omega. In the place of v, I can write down r omega whole square by r. We can write down no speed. V is equal to r omega. We can write down. So then r omega square by r. So then centripetal acceleration is r square by r. R will be left into omega square. So centripetal acceleration is equal to r omega square. That is the centripetal acceleration. We require the radius and angular velocity. Okay, na? Yeah. So then centripetal acceleration is equal to radius value is 2, but what is the omega value? Omega value we don't know. Omega value as the time changes, omega changes. Particular time is equal to 2 seconds, omega is required. At time is equal to 2 seconds. At time is equal to 2 seconds. What is the omega value I can write down? Omega I can write down as 2 plus 40 plus t square. That is the expression I have given. So omega is equal to 2 plus 4 into 2 plus 2 square. So what is the omega value goes to? Omega value goes to 2 plus 8, 10, 10 plus 4, 14. This is 14. Omega value is 14. Okay, na? Omega value is 14 I got. 2 plus 8 plus 4. 14 radian per second. Okay, na? Let me know if I did any mistake in the numbers. I think so. There is no. 2 into 14 square. Okay, na? So what is the centripetal acceleration will become? 14 square. What is the value? Final answer. Manish, I think one answer is correct, other answer is wrong. Final value 392. Manish? Right, okay. Final value 392. 392 meter per second square. So nobody has given this answer. Okay, so this is the acceleration of centripetal acceleration, that is tangential acceleration. Understood how to do it? So all of you clear how to solve the centripetal acceleration and tangential acceleration if a function is given? So like that one relation you need to make up to the other quantities. So that technique you need to understand. Praveen, no answer given by you today. Didn't get any answer, Praveen? Okay, write down all of you and then we'll go to the next part. So just once we revise the uniform and non-uniform circular motion. Revise means already I have told some ideas previously. Now let us go to the next part. Okay, Sai Charan. Praveen completed. What about remaining? Remaining also completed or not? Okay. Vestry also completed. Bhavana also completed. Okay, wrote down, everyone? Anybody is copying? Let me know. So otherwise we'll go to the next part. Completed. Okay, Nazia also completed. Okay, Lahari also completed. Okay, yeah. So let us go to the next part. So in types of circular motion, there are different types of circular motion. Okay, according to the motion, according to acceleration of the particle, according to acceleration of particle, we can make into two parts. One is called as uniform circular motion. Already I told this part. Okay, somewhere I explained it. Again, we are going with a particularly uniform circular motion. So what is the uniform circular motion? Uniform circular motion means speed of the particle, tangential speed, obviously. Speed is nothing but, speed of the particle is nothing but the direction of velocity will be along the tangent always. Okay, in circular motion, the velocity should be along the tangential direction. No other alternate for that. And centripetal force always should be there towards the center. Okay, yes. So we are making the types of circular motions into two. One is uniform, other one is non-uniform according to the acceleration. So speed is constant. So or omega, angular velocity is constant. Whenever speed constant or angular velocity constant, then that motion we call it as what? Uniform circular motion. Okay, that motion is uniform circular motion. So as the particle is going in a circular path of radius some, let us say r, then what is the particle velocity is something like this, tangential. Okay, na? So everywhere what is the speed is? Speed is v. So when speed will be constant, I told this part also. So yesterday last class we are having the a good discussion related to speed, increasing speed, decreasing speed, constant. Body does not move, Manish. If body is moving, then radius, how radius will be constant? Acceleration will be towards the center, but velocity is in another direction. Body motion will be decided by at a particular instant, body motion is decided by the velocity. Later on, who will decide the body motion? Acceleration. Acceleration is a cumulative effect. Instantaneous effect is velocity. It won't move, no? It should not move. Should not ask this question, Manish, because particle will go in a circular path. Particle is going in a circular path. Means what is the distance of the particle from the center is always constant r. That means particle should not go towards the center. You are talking about only acceleration. Let us see the velocity also. How the velocity is tangential, no? Velocity is tangential. That's why it is moving in a circular path. Praveen, angular velocity, angular speed constant, I didn't say. It depends on angular velocity also can change. It depends on alpha. If alpha is there, here in this uniform circular motion, angular velocity constant. Angular velocity constant, that's why angular acceleration is 0. Okay, na? Here angular velocity is constant, but not linear velocity. Linear velocity changes. Okay, so linear velocity changes. Why linear velocity changes? Because direction keep on changing. Who is changing the direction? Centripetal acceleration is changing the direction. Getting my point? Centripetal acceleration is changing the direction, but there is no tangential acceleration. There is no force acting tangentially. That's why speed is constant. Okay, na? So, but linear velocity changes. Speed is constant. See, speed is constant, but linear velocity changing. Because velocity is nothing but magnitude and direction. No? Here magnitude is not changing, but direction is keep on changing. So that's why, because of linear velocity changes, we are getting the acceleration towards the center. Understood? Wait, listen to me, Praveen. If you are mixing every idea, then there will be some confusion. So just follow my words, first of all. Okay, na? So whatever I'm explaining, try to understand. Then think of your analysis after the class. That is the best way to learn. While I'm explaining only, you are thinking, then everything will mix up. it will become a khichdi in the brain. Okay na? So linear velocity changes, but what about the angular velocity? Angular velocity remains same. Angular velocity remains constant. Angular speed constant, even angular velocity also constant. Why? Because how the particle is moving, particle is rotating in anti-clockwise sense, then what is the angular velocity direction? Angular velocity direction is out of the board. So then angular velocity direction is out of the board, is always out of the board. Velocity direction is not changing. Angular velocity is always out of the board. So that's why angular velocity remains constant, but linear velocity direction keep on changing. So that's why linear velocity changes. But speed remains constant. Try to understand all these logics. Okay na? So this linear velocity changes. This leads to what? As linear velocity changing, this leads to centripetal acceleration because velocity is changing. But angular velocity remains constant. This leads to angular acceleration is 0. Angular acceleration is 0. If angular velocity constant, angular acceleration should be 0 only, na? Alpha 0. If alpha is 0, then what is the tangential acceleration? What is the tangential acceleration? Which is 80. What the tangential acceleration is? Tangential acceleration will be 0 because tangential acceleration is r alpha. Okay, na? If you want, you can write down that expression also. What is the tangential acceleration we know? R alpha, which is equal to 0. Or else tangential acceleration, already we have done something like this, dv by dt. Even if you are taking this, that also 0 because v is constant. Okay, rate of change of speed is the tangential acceleration. So that's why dv by dt is 0. All of you okay? Understood? So that means in uniform circular motion, particle will have only one acceleration. There won't be other acceleration along the tangent. Along the tangent, there is no acceleration. There should not be any acceleration. Whenever there is no acceleration along the tangent, then only we call it as uniform circular motion. Then speed remains constant. Omega angular velocity remains constant. Angular acceleration is 0. But because of linear velocity changes, you will get the centripetal acceleration. Okay, na? So there will be centripetal acceleration, or else you can say that there will be centripetal force. Okay, na? Either centripetal force or centripetal acceleration, which is mv square by r, which is equal to mr omega square. Also you can write down centripetal acceleration or centripetal force. So centripetal acceleration is v square by r by mass, which is r omega square. Also we can write down. That's called as uniform circular motion. Clear? When tangential acceleration is 0, then circular motion we can call it as uniform circular motion. All of you okay? Write down. Kavishri understood? Good. Praveen, correct. Okay, what about others? Wrote down or writing? Wrote down, completed, Larry? Okay. Even Adil also switched off his video. Previously it was on, it is switched off. Now number of videos switched off are more. Completed. Okay. Chandramohan Reddy, as usual. Vamsi Krishna Reddy. Sai Charan, Grace. Sai Charan, నువ్వు కూడా వీడియో ఆఫ్ చేసావా? టైప్ చేస్తున్నా అనుకుంటా. భార్గవి. ఓకే. అలా ఫిర్ అవుట్ అవునా? Sai Charan, okay. You're using laptop, huh? Wrote down, everyone? Completed, huh? Okay. So next one is what? What is the next type of circular motion? Non-uniform circular motion. One is uniform circular motion, other one is non-uniform circular motion. Okay, na? So in non-uniform circular motion, what is the difference? Difference between uniform and non-uniform circular motion. So there will be a tangentially force acting. Okay, na? If a particle is going in a circular path, okay, so it will have, definitely it should have the centripetal acceleration or centripetal force. Without this, there is no question of circular motion. Okay, so let us say that velocity is in this direction. Velocity tangentially is there. Then there can be a force. There can be a force or there can be an acceleration along the tangential direction. Okay, na? Tangential acceleration should be not equal to 0. It can be in the direction of velocity, it can be opposite to direction of velocity. You can take opposite also, not only in the direction. Okay, na? If you want, I'll draw the one more diagram. Okay, na? So both the diagrams I explained already in the last class. Once verify the notebook. Okay, now this is the velocity. So centripetal acceleration is compulsory. Then how the tangential acceleration is? Let us say it is opposite. Okay, now so what is the angular velocity direction? Suppose particle is rotating in this way. What is the angular velocity direction? Angular velocity will be out of the board. Angular velocity will be out of the board. Here acceleration is in the same direction of speed. Then speed is increasing. Speed increases means omega also increases. Then what is the direction of alpha? Direction of alpha will be here same direction because accelerating. Here particle accelerates. Here particle is decelerating. Opposite acceleration. Acceleration opposite means force is opposite. Force is tangentially force is acting. Tangentially force is acting opposite to speed, opposite to velocity. Then what happens to speed? Speed decreases. Then alpha direction will be opposite into the board. These are the alpha and omega directions. Okay, na? So in this case, then particle speed or angular velocity, anything, speed or angular velocity increases, whereas here speed of the particle or angular velocity decreases. Okay, na? It's not speed by omega. You people will write down as speed by omega. Okay, so speed or angular velocity decreases. Okay, na? So both are called as what? Non-uniform circular motions. For what is the meaning of non-uniform circular motion? Tangential acceleration is not equal to 0. So there is a force along the tangent or there is an acceleration along the tangent. So under this condition, what is the net acceleration of the particle? Net acceleration of particle in non-uniform circular motion. Non-uniform circular motion. Tell me, what is the value? What is the net acceleration of particle in non-uniform circular motion? Net acceleration of particle is equal to, I can write down, root of, see, this is one acceleration, this is other acceleration. How the angle between these two accelerations are 90. One is radial, other one is tangent. One is radial, other one is tangent. Okay, na? So what is the angle between them is 90. Tangent is always perpendicular to radial. So two vectors are there, two vectors are at an angle 90. Then we have to find out the resultant vector, resultant acceleration, net acceleration of the particle in non-uniform motion I am finding. Okay, na? So there are two vectors, I want to find out the resultant. Then what is the resultant I can write down? I can write down something like this. AC square plus AT square plus 2AC into AT cos, what is the angle between them is 90. Simply we can write down root of A square plus B square also, but just I want to show you that I am using the vector resultant formula, root of A square plus B square plus 2AB cos theta. Okay. Then what is the obviously third term? Third term goes to 0. As third term is 0, then what is the net acceleration value I can write down? Net acceleration value root of AC square plus AT square. That is the net acceleration. Then this particle will have some net acceleration in this sense. This is the net acceleration, okay? This is the acceleration direction, net acceleration of the particle direction. So if it is making an angle, if it is net acceleration is making an angle, some beta, I'm writing beta because alpha already we used. So that's why I'm using the beta. Okay, na? So same diagram I'm drawing here because everything I'm drawing in the same thing, so it will be confusing. One acceleration is centripetal acceleration, other acceleration is what? Tangential acceleration. Okay, na? So what is the net acceleration will become? Net acceleration is something this. This is the net acceleration direction. Now net acceleration is making an angle beta with what? Beta with the tangential thing. Then what is the beta value? What is the beta value will become? Beta value resultant only, na? So tan beta is equal to what I can write down? Tan beta is equal to, tan beta will be, opposite side will be AC. Now construct a parallelogram. Construct a parallelogram, or you can use the triangle, anything is okay. You can draw the here AC, centripetal acceleration vector. Then tan beta is equal to opposite acceleration is centripetal acceleration, adjacent acceleration is tangential acceleration. Then I can write down simply AC by AT. Then what is the beta value goes to? Beta value goes to tan inverse AC by AT. Okay, na? So that is the beta. What is the beta? Beta is the angle made by net acceleration, angle made by net acceleration with the tangent. Okay, na? Angle made by net acceleration with the tangent is called beta. That beta value is equal to tan inverse centripetal acceleration by tangential acceleration. Centripetal acceleration means you can use r omega square logic. Tangential acceleration means you can use r alpha. Okay, na? So you can write down r omega square by r alpha. Omega square by, you will get, if you want you can extend the formula, your choice. Just I have given the fundamental formula. You can go in any way of your choice. I can write down in this way, right? So then r and r cancel out. You will get tan inverse omega square by alpha. Here also root of, you can write down r omega square whole square. Then this is r alpha whole square. You can take r's outside. You can further extend root of omega raised to 4 plus alpha square. I have taken r out of the expression. All of you okay? Understood? Write down this. I think you understood the non-uniform circular motion. Okay, in non-uniform circular motion, the speed of the particle may increase or decrease. It depends on the acceleration or tangential force direction. Okay, so that is the thing you need to understand. Write down this. All of you clear? What is a uniform circular motion? What is a non-uniform circular motion? Okay, Kavesri completed. What about the others? Others wrote down or not? So net acceleration directions. Now you try to draw the what is the net acceleration direction for the second diagram. Try to draw the net acceleration direction for the second diagram. First diagram I drawn, second diagram you try to draw. What is the net acceleration direction? Okay, wrote down now? Vasu, nice car, huh? N Vasu. Car is very nice. But if you remove the car, no, then you will get a chance to sit in that car. Understood, Vasu? If you remove that car, and if your video is on and you are following the things, if you follow the things very well, then you will get a chance to sit in your own car. May not be that car, but another good car. Or otherwise, you keep on putting this car in your profile pic only. That's it. Okay, wrote down? Writing. All of you understood the difference between uniform and non-uniform circular motion? What happened? Nobody is responding? Understood? Huh? Okay, okay. All of you completed? Huh? So we'll see the some other types of circular motion. One is called as horizontal circular motion. Other one is called as vertical circular motion. So that we'll see on Tuesday, because Monday is paper discussion. No? Tomorrow is the examination. Do well. Okay. And think about each and every question and do. So don't unnecessarily write down whatever option you like. Unnecessarily put your option. Solve it and take a decision to keep the option or not, because native marking is there, I think so. Okay. So that's why write down the exam carefully. So Monday we'll discuss the question paper, and on Tuesday again we start with the circular motion. Next week circular motion will complete. All types of circular motions will complete that part. Okay. Okay na? Yeah. So bye everyone. All the best for tomorrow examination. Write down well, and on Monday we'll meet. Okay. Bye everyone. Bye. All of you wrote down. Anybody writing? Kaveshri, bye. Let me know if anyone writing. Charan Teja, bye. Bye everyone.